Hello everyone, my name is Abdullah, this is Sahit and this is Tarun Sai. And today we have made a project which is known as the Smart Dustbin. So the Smart Dustbin is a project that we have been working on for a lot of time and now we have made it. So this project is mainly focused on people who mainly called senior citizens, which is why we have made this project and making life much more efficient and easier for people. So why the smart dustbin? Smart dustbins help to create a cleaner, safer, more hygienic, environmental and enhanced operational efficiency free.
Advantages of the smart dustbin. We believe that the smart dustbin is very efficient for people, especially senior citizens. It is also more hygienic as it minimizes contact. It reduces traffic. We can reduce traffic through reducing the number of visits the garbage trucks do to the deposits, and by this we can also reduce the air pollution.
The components we used in the smart dustbin are servo motor, battery, sensor and Arduino.
So now I'll be explaining the functions of each component. So first, the main part of this entire project is the ultrasonic sensor. The ultrasonic sensor can be more or less known as a projectile sensor. Next comes the servo motor. The servo motor is a linear and a rotatory motor which can rotate 360 degrees and it can also rotate with certain velocities and certain acceleration amounts. Then comes the Arduino board. The Arduino board is the place where we can input our code, and the good part about this is that the Arduino is an open source board and then we can recode it again and again. So as you can see here, whenever we put our hand here, the servo motor rotates 180 degrees and hence raises up the lid so that the smart dustbin's entire concept works. So here is the circuit diagram. The circuit diagram, as you can see here, is the servo motor, the Arduino, the 9-volt battery as I told, and then also the ultrasonic sensor. First comes the yellow pin of the servo motor, which is connected to the digital pin board of the Arduino, so that the code directly goes to the servo and then the servo can move accordingly. Then comes the power supply pins of the servo motor, which goes directly to the power board of the Arduino. Then comes the 9-volt battery, but instead we have used lithium-ion batteries, as you can see. And then the power supply goes to the power board of the Arduino, and then the Arduino provides this power to the servo motor and then the ultrasonic sensor for it to operate. Then comes the ultrasonic sensor. The ultrasonic sensor here has four pins, which is the VCC pin, the trig pin, echo pin and the GND pin. The VCC pin provides power supply for the ultrasonic sensor. The trig pin triggers ultrasonic sound pulses. The echo pin produces pulses when the reflected signal is received. And about the GND pin, which is over here, is connected with the GND pin of the Arduino board for maintaining its connection.
The mechanism. When there is any interruption within 30 centimeter radius of the ultrasonic sensor, it opens up the lid. The ultrasonic sensor sends the signal to the Arduino and the servo receives the signal from the Arduino. By this, when there is an interruption with the sensor, the 9G servo gets the signal and lifts up this lid with the help of this knot here, a demo. That's how the mechanism works. Thank you.